Now let me talk about the Bernoulli distribution. So the first one in the list, which is called as the Bernoulli. Yes, by any chance, were you able to remember any points with respect to Bernoulli? Again, your 8th or 9th standard topic.
Yes, sir, I
Anybody?
remember. So it is the distribution mostly associated with the experiment which is having only two outcomes.
Excellent. Right. So guys, always remember the moment you're trying to deal with an experiment which has only two outcomes. That's it. It means it is always dealing with respect to those statistical experiment which will always have binary outcomes. So when we say binary, obviously it will be yes or no, success or failure, ones and zeros, etc. Okay, but when we talk about Bernoulli distribution, we need to remember two other important things, right? So while remembering only two outcomes is one of those key point with respect to Bernoulli distribution, the other two important things that you need to remember is this particular experiment has to be carried for only single trial. What does that mean, guys? When we say single trial with respect to these experiments? In case of your probability, when we say single trial, what does that mean?
Can be applied only once.
Can be applied only once. It means the experiment has been conducted just for once. Okay, so that is the second important thing that you need to remember. And the third important thing that you need to remember is the probability of success and failure need not be equally likely. What does it mean?
Equal means it should not be same
Give me an example. If you understood, you could be able to express this with an example, isn't it, guys? What does it mean? Equally likely.
It cannot be independent values like.
Let's not overcomplicate. So guys, simple. So the moment we think about binary outcomes, it is a human tendency to always think that maybe the probability for each one of those outcomes might be 0.5 and 0.5, isn't it? General human tendency to make certain assumptions or having some kind of misconceptions when we try to deal with respect to binary outcomes. But when we say the probabilities of success and failure, the two outcomes of this statistical experiment need not be equally likely. It means it need not be always like tossing a coin. Guys, what is the probability of each one of those outcomes of this experiment called tossing a coin?
0.5.
0.5.
Yes. So it means we should not be under assumption saying that when we have two outcomes, we tend to think that maybe it would be similar to that of a tossing a coin. No, that need not be the case, right? It has to have two binary outcomes, right? It has to have a single trial, and the probabilities of these two outcomes, mainly called as success and failure, need not be equally likely. It means the probability of success could be 0.2 and the probability of failure could be 0.8. The probability of success could be 99.999 and the probability of failure could be 0.10001. Make sense, guys? Are we clear? So these are the three important things that you need to remember when you're dealing with respect to Bernoulli distribution. Are you clear about this? Any questions? Two outcomes, single trial, need not be equally likely. Simple. So this is how you can remember a Bernoulli distribution with respect to three main attributes. Are you clear on this?
Yes.
Excellent, right? So namely, the success is generally denoted as P and the failure denoted as Q. Since we know the success, right? Since in the world of probability, if you know one of the success value, the failure could be easily calculated as 1 minus P, which is represented as a Q. Makes sense, guys? Clear?
Yes, sir.
Very good. So since Bernoulli is a discrete, whether we'll have PDF or PMF?
PMF.
It would be PMF. Okay. So let's try to select how the Bernoulli distribution, right? The probability mass function will look like. It is generally represented as whenever the x is a failure, the general failure is denoted as 0, and the respective probability would be 1 minus p. Okay. And when it is a success, when x equal to 1, the probability would be 1. So it would be p. Right. The other way of trying to write this equation is it can also be, right, it can also be written as following, right? So we generally denote as p to the power of x multiplied by 1 minus p to the power of 1 minus x, right? The moment you substitute the x equal to 0 and 1 values, right, it will again boil down to this particular equation, right? So let's try to substitute and try to see whether it's in the same form or not. So when I substitute x equal to 0, guys, what is p to the power 0?
Sir.
What is p to the power of 0?
1, sir.
1. And what is 1 minus p to the power of 1 minus 1? So 1 minus 1 would be, sorry, 1 minus 0 would be 1. So 1 minus p to the power of 1. What would be the value?
Minus P.
1 minus p. So the reason, so when x equal to 0, it could also be written in a little mathematical equation format, just this. Clear? Any questions? Any questions? Okay, we forgot to write the third point, right? So guys, what is the third point? Two outcomes, single trial, and what was the third point?
Would be equally likely.
It need not be equally likely. So this is very, very important. So this is how you can label a particular statistical experiment results, and we can associate this with respect to either following a Bernoulli or not. Okay. And as an example, right? I'm a big fan of WWF. So let's say like there's a wrestling match between you and John Cena. Okay, guys, what is the probability of success?
Sir.
See,
Nil.
when you're going when you're going to go for such kind of a match, right? So definitely you prepare for something, right? I would definitely rate myself as at least 0.000001, isn't it, guys? Right? No?
Yes.
Yes, definitely, right? So this is how I just try to say. It means always remember that a binary outcomes does not mean that the probability would be equally likely always. Okay? Okay, are you clear? So since we are trying to talk about the probability distributions, right, so we need to talk about the expected value and variance. Again, we will not be using this as part of anything, but right. So the E of x, the expected value of such kind of a Bernoulli distributions would be the probability of success. And coming to the variance, right? So the variance formula is E of x square minus E of x whole square, right? So when I try to substitute E of x and E of x whole square, what I will be getting is P into, it would be P into 1 minus P. Okay, so this is how the expected value and variance values are with respect to your Bernoulli distribution. Any questions here, guys? And when you wanted to look at the how the graph would look like, right? So this is how the graph would look like. Okay, and why 0.1 as an example, right? This is just an example to just show you. So it need not be always 0.5 and 0.5. So you might be getting any other values too with respect to your success and failures.